Welcome back to this series of introductory videos on how to use Unix, aimed at people doing the FSL course. In the last one we saw how to do mkdir and how to do mv, and what the difference was between relative and absolute paths. So now we'll just try a couple more commands so that we can get used to how to move files around. Okay, so I'm in my home directory at the moment in this terminal. I'm going to go back into our UnixIntro directory. You might have seen that I can type very quickly sometimes. That's actually by using the tab key. So if you actually, let's try that again. If I start typing something, so like uni, and I hit tab, it'll immediately expand that if there is something there that starts with that name and if it's unique. If it can't figure out things, then it will expand as much as it can. In this case, it's given me everything. That's a useful little tip to know. Try the tab key every now and again. Okay, so I'm in this directory. We saw last time we made a directory called info within that, and we moved some files into that. So the rest of the files we've got in this directory now all have this extension nii.gz, and that happens to be the format of the nifty image, which is what we're going to be using for our neuroimaging data. It's the standard format that we would all use. You might be getting things like DICOM format off your scanner. You'll need to convert that to nifty format in order to use the FSL tools. And there are many different tools available to do these kind of things. Okay, so now let's actually try some FSL commands. So FSLize, or fossilize, which we prefer to call it, is the viewing tool that we have. So I'm going to run that now. So if I type that in my terminal and press return, it will bring up a window which is the fossilized viewer. So that's just going to take a couple of seconds and then it's here. From that I can add files to have a look at. And so I'm in my UnixIntro directory, I can pick any of these files. So let's pick the first one here. I'm going to open that and then that's going to show me this image. Okay, so I'm not going to go through how to use fossilize. That's covered in the first introductory practical of the FSL course, part of the preparatory material that you'll see on the website. So that's something that we've got a walkthrough for, which you should have a look at and you should try yourself, particularly if you've not used the fossilized viewer before. Okay, so that's a way that we can get an image up and have a look at it. But what I'm interested in now is actually how it interacts with the terminal. So now you can see that I've typed fossilize and now I've got a cursor here but I've got no prompt. So this part here is what we call the prompt. It always ends with $sign for me. It may end up with something different on your particular system. Again, it's one of the things that can be configured for different systems. So it might be percentage sign or a greater than sign or something else. But there's always a prompt every time that you get to type a command. So you see the commands that I've been typing here, they all have a prompt in front of them. Now I don't have a prompt, and that means if I type something like ls, nothing happens. And that's because once I started this viewer, that's all it's going to do. It's going to keep running the viewer until I quit the viewer, in which case I can use my terminal again. Until I do that, I can't use the terminal. But there are other ways that I can try and get my terminal back. So the first way is, as I said, if you quit the viewer, then all of a sudden you restore the terminal to being functional. It will then actually do the ls command that you asked it to do. But there's another option, which is actually to put this symbol, an ampersand symbol, after the fossilize command. If I do that, then I actually start fossilize, and you see that it starts again, and I can load my image. For instance here, let's load this same image. But I can also go back here, and I can immediately use the terminal. I've got my prompt already, and I can run things. And that's because it's running this in the background. That's what we call it, running in the background, so that the terminal and fossilize run at the same time. And I can use both of them. And that's a really good way of actually doing things. So particularly for graphical interactive things like the viewer, you want to get into the habit of using the ampersand. You don't want to do it for other things like ls. I don't want to do ls with an ampersand. I want ls to actually run in the terminal. But for things which are going to run outside the terminal, that's a useful thing to do. If I had happened to start it without remembering to put my ampersand in, then as you saw before, I'm still going to be able to actually load an image and use the fossilize viewer, but I can no longer actually do anything useful in this terminal. But I don't have to quit fossilize in order to get control back. Another option I've got is to make this go to sleep. And to do that, it's Control Z. So think of sort of Z as this sort of going to sleep. So Control Z will make this fossilized viewer go to sleep and give me my terminal back. So now I can do ls and I can do other things in my terminal. But if I go back to this fossilized window, you'll actually find that it's not responsive. Okay? That's because it's actually asleep, as we said. It's not actually running anymore. But if I want to have it running in the background, I can just type BG for background, press return, and now fossilize is again running and responsive. So I can do things with it. So they're your options. Either use the ampersand after the command, particularly for fossilize or other GUIs that you might start invoking from the command line, or try Control Z and then BG. Both of those are good ways of doing things. Okay, so that's all I'm going to say about running fossilize. You'll also see these little things like done and stuff like that. That's just telling you about things which are running in the background. Here it told me that I'd put it to sleep because of my Control Z. And it's worth knowing that this little hat that you get before letters is a shorthand in Unix for control and that letter. This is a shorthand for Control Z in this case. Okay, so now I've got my terminal, I can do ls. We can do other FSL commands in the terminal as well. So one of the commands that we've got is FSL maths. And that would allows us to do things like add images together. And so one of the things that we could do is to take that image that we had before and we could add it to a second image like this, and we could save our result in something like that. And so this is an example of a command line call using the FSL tools. So if I do that again, I run it and it doesn't tell me anything, which is the normal thing for Unix when things are going well. If I'd tried to do that same command, but I'd made a typo, so now I've done in instead of im, then it wouldn't be happy and it would give me an error message. The exact error message you get will depend on the mistake that you've made, but you'll see some kind of error message. The most common one that you'll see is something like can't open file or can't find file or directory. Those normally indicate that you're either in the wrong location, so your present working directory is not correct for the path that you're trying to specify, and if you use ls you'll be able to tell whether the file or directory that you're looking for is actually where you think it should be based on where you are now. So that's the first thing to check, and then also check for whether you've made typos. And they're the most common things that you'll run into, the most common mistakes that you make. Okay, so let's learn another command. So the command we're going to learn now is the way to delete a file, okay, or remove. And the shorthand for that is rm. rm for remove. So if I do remove that, and I press return, then in this case it's going to ask me, do I want to remove it or not? So I'm going to say yes, and then if that is the case, then it's done. Now, that might not be the same on your system. It might just go and do it without even asking you. Either way, if it's either done it straight away or you've said yes, that file is removed. It's not in the trash, it's removed, it's gone, you're never going to get it back. So this is the one instance to be very careful in Unix. You really want to make sure when you're using remove commands that you are doing the right thing. If you make a mistake in the remove command and you've removed something you didn't intend to remove, I'm afraid that it is just gone. So it's important to keep backups and it's important to be careful when you're using that command. It's really the command to take the most care about when you're actually using Unix. Okay, so let's look at another command now. Let's look at the copy command. So the shorthand for copy is cp, and I can do that by just doing copy. Again, I start with one particular name, and then I can give it a second name. And if I do that, then I'm going to make a copy of what was this high-res image file, and it's going to make one called structural. And if I have a look here, then now I've got a thing called structural. I'm now going to remove that, so we go back to where we were before. Okay. An alternative thing that copy can do is to make a copy into a different location. So let's imagine that we've done this, and we wanted a copy of this file in the info directory. If I just did that, what it will do is it will make a copy of that file in the info directory, but it will keep the same file name. So if I just do this, and now I have a look inside my info directory, then you can see that I've got now a highres.ni.gz in this directory where we didn't have one before. Okay, and so that's how copy works. You can either copy a file into a different location and keep the same name, or you can use copy to make another copy of that file with a different name. It basically works the same way. You might also want to copy a whole directory's worth of stuff. So, for instance, we've got this info directory with 4 different things in it. Let's say that we wanted a different copy of that. If I just did copy of info to say info backup, that's not going to work because copy is intended to work with just files. But copy, like most of the other Unix commands, actually has a rich set of options which allow it to do other things. So in this instance, there's an option that is a recursive copy, and it allows us to copy a whole directory tree into another whole directory tree, or a copy of that. And the command is called -r. So if we do copy -r info to info backup, then that will do what we wanted. I now have a directory called info backup. If I have a look at that, then I can see that it contains the same files. If I removed one of the files in info, say I removed this high-res file, then we can see inside info I now have 3. Inside the info backup I still have all 4 files. And so that means that this is it's a full backup, it's a full copy of what I originally had, and I could actually do something like this. Copy info backup high-res into info. I could put a slash here if I wanted, and I could give it a different name. I could give it new high-res if I wanted, and that would make it like that. Or I could just say info and copy in high-res, or I could put a slash there and that would do the same thing. Info or info slash in this case is going to mean exactly the same thing because it's the name of a directory and it's just telling me where to put that. So this is actually a case where we're copying from one location, the info backup subdirectory, into another location, the info subdirectory, without ever moving away from the directory we're currently in, which is UnixIntro. So there are 3 directories really. There's the present working directory, which this terminal is sitting in, and then there are these 2 places that I'm copying from and copying to. And they don't have to be the same as the present working directory. And you'll see this kind of method of working with commands as well. So I could do that, and then if I did that, I would see that I was in info. I could have done that another way. I could have CD'd into info backup, actually moved my terminal into that directory and done that instead. So let's try that. So let me again remove the file from info. So now let's just check info and info backup are now different. Info is missing this file. So let's say that instead I went into info backup. Again, you can see that I've got a slash here. That's because I used the tab key to expand the path, and it doesn't matter. A directory name with a slash at the end is almost always the same as just using the directory name itself. So now I'm in info backup. You can see that I can see those files, and let's say that I want to do the same thing. I want to make a copy of high-res and put it into info, because let's say that this remove command that I did was by mistake. I didn't mean to get rid of that, and actually I want to restore the backup version of it that I had. So I could do that. I could copy high-res to that. Now I have to tell it how to find info. So info is not currently in this directory. If you see the ls from info backup that I'm in, it just has these files. But we know that it's in from the directory above. So if I do ... that would be the directory above, which is UnixIntro. If I did then info on top of that, then that would copy it where I wanted to. So now if we go back up one and look at info, then I can see that I've got that, and my info backup also has a version of it. So you can see that this way of doing it, where I first cd'd into the info backup directory and then I copied it, I had to use a different kind of relative path. I had to go up one and then down into info, because I started at info backup, and I went up one into UnixIntro, and then I went into the info directory after that. Okay? So again, it's good to get familiar with how relative and absolute paths work. All of these are relative paths. I could have, at any point, also done a copy of, I'll show you. So let's go back into our info backup directory. Okay, I also could have done a copy of high-res and then used the full absolute path to where I am. So that would be UnixIntro, and then it would be info, because that's where I wanted to go. So this is the full absolute path for the info directory, and I could have just copied it into that, or I could have also given it a new name. So I'm going to give it a new name now because I've already got a version of it that I copied before. And if I do that, that's quite happy. If I go back and then go into the intro directory, oops, not the intro, the info directory. So you can see, I made a mistake, and that's what it told me. Now I can see that I've got high-res and high-res 2. So again, a third way of doing this kind of copy. Use a different name here, but if I didn't have a version of high-res already, then I could have left that off and it would have just done a copy of high-res itself. If I went back into my info backup, so now I'm currently in info, I'm going to move into info backup by going up one and back. So now instead of doing 2 cd commands, I'm doing them all together. So again, getting used to how I can join together parts of a relative path. That's now info backup. Okay. So let's say that I tried this command before. Copy and paste that. If I tried to do that, then it's going to try and take this file, high-res, and it's going to try and copy it into the info directory, but I already know that in the info directory I have a file of that name. If I try and do that, then it's actually going to do it, and it's actually going to have overridden that file. So that's another thing to be careful of. Again, this might be set up slightly different on different machines. Some machines will ask you a question in the same way that my machine asks me when I want to remove a file, if I really mean it. Sometimes they'll detect that a file already exists of that name, and they'll ask you if you really want to do that or not when you do a copy. But they might not. In my case, it doesn't ask me that. It's just replaced that file that I had before with this new one. And so that's worth remembering and realizing that, again, you can do something bad, you can overwrite a file by using copy if you're not careful. So be very careful using both remove and copy. Okay, so that really rounds out the simple commands that you need to get a good grip of in order to be able to use the FSL tools. There are a couple more videos in this series to take you a little bit further and give you a little bit more information, but the information that we've got to so far is the most crucial. So make sure that you go away and you try these different things yourself. Don't necessarily stick to exactly the same things that I was just doing. Experiment yourself. Just make sure that you try and stay within the Unix intro directory and that you don't accidentally remove or copy over something else. They're the only real commands that you have to be particularly careful with. So just try different things and experiment with different commands and make sure that you understand what's going on so that you can find different files and you can move them around. I'd suggest trying, making these directories like like info and info backup and moving things around between the different directories. That will give you a lot of information and a lot of practice in how to actually use these relative paths and how to do these simple Unix commands, but ones which are really crucial in order to be able to actually be able to use the terminal effectively.